might be hearing a splashing sound. That is the sound of Virgil drinking some water. Would you like to see Virgil? Virgil, say hi to your favorite audience. Your fans. Okay, yeah, he's busy. Look at how nicely his scar is healing, guys. Isn't that great? Okay. Whew, hi. Okay, here we go. Let's get back to school. Yay. I miss you guys. I hope you're having a nice day. Okay, so compare your answers to 4 and 5. What do you notice about them? Well, of course, we saw that they were the exact same number. Same number, same unit. And so, what does that tell us about the relationship between work and change in energy? They're equal to each other. They're the exact same thing. Okay? So then, hopefully you are explaining that in complete sentences in your own words. That's what I'm looking for in this question right here. Let's go ahead and do number 7 together and just make sure that everybody was on the same page with it. So, it takes 55 seconds for the roller coaster car to be lifted from the 5-meter position to the 45-meter position. How much power did the motor have to generate? Okay, so we know that that is work divided by time. So from above, we know that the work was 482,160 joules. And then we're going to divide that by the time, which is given right here, 55 seconds. Okay, and so we do 482,160 divided by 55, and we get 8,766. Let's round this off to the closest whole number. So this is 5 or bigger. We're going to round that up. That's going to be a 7. And the units for power are watts. So we're going to put a capital W there. So let's go ahead and do 8,767 watts as our answer right here. If you ever take a look at your parents' electric bill, or even if you look at energy on different light bulbs or things, a lot of times you see, instead of watts, you'll see kilowatts or kilowatt hours. How many kilowatts do you think this is? Well, if a kilo is 1,000, then we would say that this is 8.767 kilowatts, because a kilowatt is 1,000 times bigger, so it would be a smaller number of kilowatts. All right, we don't need to write that down, just doing a little review for you guys. All right, we're on to the 3rd page of this, and I know that this looks like a great big grid of all kinds of stuff, but it's really not that bad. It's just going to be doing some practice problems. Now, one thing that I haven't taught you guys yet is the equation for kinetic energy. And that's actually a tricky equation. There's a little bit more math in it. It is 1/2, it's a little 1/2 there, times mass times velocity squared. Now the only thing that's actually squared here is just the velocity. So I'm going to go ahead and put some parentheses around that so that you know you're squaring the velocity, not the rest of this stuff. Okay, we already learned the equation for potential energy. That was m times g times h. And then mechanical energy, that's just these two energies added together. It's just PE plus KE. That's all it is. So that's the math that we are going to be practicing on this page. I'm going to go through a couple of these with you guys together, and then you will need to complete the other 4. So there's a total of 6. We're going to do 1 and 2 together, then you're going to do 3, 4, 5, and 6. Okay? All right, let's get started. So what this does is this gives me a chart for each of these positions. At each of the positions, how fast was the object moving, and then and what height was it at. So according to this, I'm giving you that the velocity was about 3 meters per second. I'm basing that on that this cart is going to kind of get to the top, and then it's going to kind of pause for a minute, and then it'll start speeding up. By the time the end of the cart gets here, it's going to have some amount of speed. So that's why I went with the 3 meters per second. So we're going to go ahead and fill in our equation. Remember that our mass is going to be 1230 kilograms. Gravity is going to be 9.8 meters per second squared. And then our units for energy are always going to be joules. So let's do our first one. So PE is equal to mgh. So I'm going to go ahead and write in my m, which is not this. Be careful. That m stands for meters, not mass. This m stands for mass. So we're going to do the mass times gravity times height. Okay, so this number is actually height. So here we do 1230 kilograms times 9.8 meters per second squared times the height, which is 45 meters. And we've actually technically done this already on a previous page. So that answer should be this number right here. So I'm going to go ahead and write that that equals 542,430 joules. Okay. Now I want to know my kinetic energy. So for my kinetic energy, that is going to be 1/2 times, this m stands for mass again, times velocity squared. Notice here that squared is actually part of the formula. Here, squared's not part of the formula, it's part of this unit, which is why we don't square anything over here, but we are going to square when we use this formula. So that equals 1/2 times my mass. My mass is going to be 1230 kilograms, times my velocity squared. That's going to be the 3 meters per second. And that whole thing gets squared. Here, I'm gonna do it like that so that you can see that that doesn't go with the seconds there, okay? All right, so what I'm gonna type in for this one is, what you can do is 0.5 if you want for the 1/2 times 1230 times, well, what is 3 squared? It's 9. So we can just do that. Or you can always do 3 times 3 to get your 3 times 3, or your 3 squared. Or if you have an actual calculator with a squared button, which, yeah, this one actually doesn't. I could do 3 raised to 2, which is 9. And then that times my 1/2. So I could do 1 divided by 2 if I wanted to here. Okay. And then I could do that times 1230. And yeah, all right. So it gets me the same thing regardless. But so however you want to do it, just make sure that you're following your order of operations. Make sure, why did I write a 3 there? I meant to write a J for joules. Just please make sure that you are only squaring the speed when you do that. And the only place you're going to do any squaring is in the kinetic energy, okay? All right, so lastly, we are adding up our mechanical energy, which is our potential plus our kinetic energy. So PE plus KE. So that is going to be our potential energy, 542,430 joules, plus the kinetic energy is 5535 joules, And that equals, let's do 542,430 plus 5535. Okay, here we go. 547,965. There we go. All right. Why don't you take a minute and see if you can plug in the correct answers for this second line. Try to go ahead and calculate those, and then we're going to see if our answers match. Okay?